Welcome to this presentation for AQA Physics topic P14 Light. The subject is reflection and refraction. So in terms of grades, the grade 5 would be the ability to construct accurate ray diagrams which show the reflection of light rays, and also to identify the angle of incidence and the angle of reflection in a ray diagram. For a grade 6, you need to explain why some surfaces form images during reflection but others do not, and be able to construct a ray diagram which shows the refraction of a ray of light at a boundary between two different media. And finally, for a grade 7, be able to draw a ray diagram showing the position of an image in a plane mirror and explain how the refraction of light can cause the depth of a material to appear less than it actually is. So there are two ways that light can reflect off objects: specular reflection and diffuse reflection, and this will affect how we see an object. So with specular reflection, if the surface is smooth, as in this object here, then we will see that the light will hit the object and reflect off at the same angle. So this is evident with these rays and those reflected rays. This produces what we call a reflection. We see an image of the light source. So this is what happens with a mirror. Now, diffuse reflection is slightly different. The issue here is that the surface is very irregular. So we can see that here. We have lots of protuberances and bumps in the surface. Now, what that does is cause the light to reflect off in many different directions. So although the light all arrives from the same direction, where it hits will determine what direction the light reflects off in. Some of that light will reach our eyes, but some won't. And this is normally how we see objects. So we don't see a reflection of them, we see the image, the object itself. Now, the law of reflection is quite simple, that the angle of incidence of a light ray is equal to the angle of reflection. So in this diagram, we see this is the symbol for a mirror, and the angle of incidence is the angle between the incident ray, which we see here, and the normal line, which we see here. Now, the normal line is an imaginary line which is drawn at 90 degrees to the surface of the reflective object, in this case the mirror. So this here is the angle of incidence. It's the angle between the light ray arriving and the normal line. The angle of reflection is the angle between the reflected ray, which we see here, and the normal again. And for any mirrored surface, so a surface that is undergoing specular reflection, the angle of incidence must be equal to the angle of reflection. When an image is formed on a mirror, certain things happen. So here we have our mirror, and we can see from this object here, light rays will travel to the mirror, and in the case of specular reflection, they will reflect off that mirror, where the angle of incidence equals the angle of reflection, and they will arrive in the person's eye. Now what happens is the brain actually interprets those light rays as not actually being reflected by the mirror, but as travelling in a straight line, and they will create a virtual image. And that virtual image is the same distance behind the mirror as the real image is in front of the mirror. So the mirror image is always the same distance behind the mirror as the real image was in front of the mirror. This is a virtual image. It's a virtual image because it's not been created by real light rays shining on the location. There are no light rays shining here, so this is not a real image. It's a virtual image. The other thing unique to mirror images is the idea of lateral inversion. Now this means that the object appears to be back to front. So we see that with this person here. This is the person's left arm, and the reflection of the person is over here. So this image is here, but this is the right arm of the image. That's a lateral inversion. Same on this side. This is the right arm of the person, but the image of that arm is on the left hand side of the image. So lateral inversion simply means that the image is back to front. This is most notable when we look at mirror writing. Next we come on to the process of refraction. Now refraction is a property of waves whereby when they hit a medium at an angle, a change in speed occurs which causes a change in direction. So we see that in both these diagrams. This is an image of refraction in water, so we can see waves coming from deep water and moving into shallow water. Now what happens is that the side of the wave that arrives in the shallow water first slows down, and this causes a change in the direction of the wave. Now light will behave in a very similar way, and what happens with light is it will arrive at the interface between the two media. So in this case we've got a vacuum and we've got another medium, could be air, and when it arrives at that medium it will slow down and it will refract, it will change direction. This is due to the speed of light changing again. The angle of refraction is the angle between the refracted ray and the normal. Again, just a reminder that the normal line is an imaginary line that is drawn at 90 degrees to whatever the interface is. Now, refraction occurs either towards or away from the normal line, and that depends on the density of the material. So, for instance, if the ray moves from a less dense material to a more dense material, as in this example here, then the light will refract towards the normal line. So we can see the incident ray arriving here. Now, if this is air and this is water or a glass block, the light ray is refracted towards this normal line because it should go that way. So that's a movement into a more dense material. We see the refracted ray pass through the material until it reaches this point. Now it's moving from a more dense material to a less dense material, and we see the angle of refraction is this time away from the normal line, because we would expect the line, if it was travelling straight, to be there. Now the amount of refraction will depend on the refractive index of the medium. The higher it is, the more refraction there is. And the refractive index of different media are given in this table, so we can see a vacuum has an index of refraction of 1. That basically means it doesn't refract things at all. And as materials get more dense, we can see that the refraction will increase. Diamonds have a very high angle of refraction, which is why when we look at them we see all those rainbow colours inside and they sparkle. Finally, we come to the idea of apparent depth. Now I'm going to illustrate this using spear fishermen and missing the fish as an example. So here we have a spear fisherman, here we have our fish. Now light rays will bounce off this fish and will travel through the water, and they will arrive at the interface between air and the water. Now air is less dense than water, so if we draw in our imaginary normal line, the refraction of this light will be away from that normal line, like so. And this light ray will travel into the eyes of the fisherman. Now the fisherman's brain does not interpret this as refraction happening. The fisherman's brain assumes the light is traveling in a straight line. So instead, the brain of the fisherman sees an apparent fish in a different position and shallower than the real fish. So when the spear fisherman throws his spear at the apparent fish, it will hit here. That will of course mean that the real fish escapes. So what has to happen is that the fisherman basically has to practice and has to learn that the fish is not there but there. So the fisherman will aim in a slightly different position to the apparent position of the fish and will hopefully hit the real fish. Now what happens here is also true for the bottom of bodies of water. So for example, a swimming pool. If you look into a swimming pool, this pool actually looks shallower than it really is. So that is due to this idea of refraction. Light rays from the floor of the swimming pool will come up refract, and then the apparent image of the bottom of the swimming pool would actually be here. Well, thank you for watching this presentation. I hope it's been useful in terms of your physics knowledge, and I'll see you again for another one soon.